Welcome to Math with Mrs. Bibb. This is week 19 in our Algebra 1 honors class. This week we'll be learning about exponential equations. Please make sure to fill in your table of contents. Complete your weekly warm-up, and we'll get right to the notes. You're going to need Student Journal page 191. Okay, let's look at the problems. When you are solving an exponential equation, what you want is the bases to be equal. So when I look at these bases, base of 3, base of 3, base of 8, base of 8, base of 6, base of 6, 5, and 5. Starting with number 5, my bases are not the same. So I'll have to do a little bit different work for number 5 than I do the rest of them. So looking at number 1 and 2 and 3, when the bases are the same, then the exponents are equal. So I can go straight to solving for x by writing the equation 4x equals 12. When the bases are the same, the exponents are equal. So I would solve that equation by dividing by 4, x equals 3. Looking at question 2, when the bases are the same, the exponents are equal. So x plus 5 equals 20. Solve that the way you've been solving for years. X will equal 15. Number 8. When the bases are the same, your exponents are equal. I'm going to subtract 4x. Negative 5 is equal to negative 2x. Divide by negative 2. X will equal positive 5 over 2. Leave it as an improper fraction. Number 4. When the bases are the same, the exponents are equal. Solve that equation. Add 3. 2x is going to equal 0. Divide by 2. X is 0. Now looking at number 5, my bases are not the same. So I need to rewrite 1024 with a base of 4. Let's see if I can do it. Over here on the right, I'm going to think about 4 to the 0, 4 to the first, 4 to the second, 4 to the third, 4 to the fourth. I have to think about this one. 16, 22, 56. 4 to the fifth. I think that's 1024. 24. 22. Yes. So 4 to the fifth is 1024. I'm going to replace 1024 with 4 to the fifth power. 4 to the 2x plus 11 is going to equal 4 to the fifth power. Now, my bases are the same. I have a base of 4 and a base of 4. Since my bases are the same, I know that my exponents are equal. So I can write my equation 2x plus 11 equals 5. Subtract 11. 2x equals negative 6. Divide by 2. X equals negative 3. Number 6. My bases are not the same. So can I rewrite 512 with a base of 8? Let's see if I can. 8 to the 0 is 1. 8 to the first is 8. 8 to the second is 64. 8 to the third, 8 fours are 32. 48, yes, 512. So I can rewrite 512 as 8 to the third power. So 8 to the 3 minus 2x is going to equal 8 to the third power. My bases are the same, so I can set my exponents equal to each other. I'm going to subtract 3. Negative 2x equals 0. Divide by negative 2. X equals 0. Okay, moving right along. Can I rewrite 256 with a base of 4? Yes, over here it is. 4 to the fourth power is 256. So 4 to the 7 minus x is going to equal 4 to the fourth power. My bases are the same, so I can set my exponents equal to each other. 7 minus x to the fourth power. Subtract 7 from both sides. Negative x equals negative 3. Divide by negative 1. X equals positive 3. Now, I don't believe, but I could be wrong, can I raise 49 to a power and get 243? I don't think so, but I'll see. 49 to the 0 is 1. 49 to the first is, 49 to the first is 49. What's 49 to the second? It's going to end in a 1. It's going to be over 343, so no. So this is a complicated one. I have to rewrite both bases. I have to rewrite both 49 and 343 with a base that might be similar. The only base that I can think of for 49 is 7. So I'm going to switch to blue and write over here with my 7 powers. 7 to the 0 is 1. 7 to the first is 7. 7 to the second is 49, so that's what I want. Whoop, and I put a 4. Whoops. 7 to the second power is 49. What's 7 to the third power? Is that 343? Let me do 49 times 7, 63, 28. Yep, 343. That's what I need. So I'm going to use these two. 7 to the second power and 7 to the third power. So 49 is 7 to the second power, but my x minus 2 is out there, so I can't forget it. 343 is 7 to the third power, and there's nothing outside of there. So I'm going to multiply. Remember in class we did power of a power. Multiply 2 times x minus 2, so that will give me 2x minus 4 equals 3. My bases are the same, so my exponents are equal. And I got the 2x minus 4 by distributing. So I'm going to go over here and try to write. I'm going to add 4 to both sides. 2x equals 7. Divide by 2. X equals 7 over 2. For number 9, can I rewrite 36 with a base of 6? And yes, I can. 6 to the second power is 36. So I'm going to put 6 to the second power for 36. It has an exponent of 6x minus 1 out there, so I got to keep it. Equals 6 to the 5x. So although I have the bases the same, I want to get rid of this power of a power. So I'd have 6 to the 12x minus 2 equals 5x. Then 12x minus 2 equals 5x. I'm going to subtract 12x from both sides. So I'm going to have negative 2 equals negative 12x. Nope. Equals negative 7x. Divide both sides by negative 7. X is going to equal positive 2/7. Moving on to these next examples, I notice on number 10 that I have a base of 9 on the left and a base of 81 on the right. I know I can rewrite 81 as 9 to the second power. So I'm going to leave 9 to the x minus 4 as 9 to the x minus 4. I'm going to rewrite 81 as 9 to the second power with 3x on the outside. Now we've been working on exponents, and so I know I have power of a power. So I'm going to multiply the 2 and the 3x to make 9 to the 6x. And then I'm going to solve. X minus 4 equals 6x. I'm going to subtract x from both sides. Negative 4 will equal 5x. Divide by 5. X will be negative 4/5. Number 11. I don't believe that I can rewrite 512 with a base of 64. 64 times 64. If I think about that, 60 times 60 is 3,600, so I can't do 64 to the second power. Can I rewrite, I know I can rewrite 64 as 8 to the second power. Can I rewrite 512 as 8 to a power? 8 to the first power is 8. 8 to the second power is 64. 8 to the third power, isn't that 512? 8 times 4 is 32. 8 times 6 is 48, plus 3 more, that is 512. So I can rewrite 512 as 8 to the third power, and then it has the x out there. On both the left and the right side, I have power of a power, so I'm going to multiply these two by distributing, and I'm just going to multiply these two. So 2 times x plus 1 is 8 to the 2x plus 2. So remember, you're distributing on the left. On the right, 8 to the third raised to the x power is 8 to the 3x. Now I can set my exponents equal since the bases are the same, and I left off that plus 2. 2x plus 2 equals 3x. Subtract 2x from both sides. 2 is what the value of x is. For number 12, I'm in good shape because I can rewrite 36 as 6 to the second power. So leave your base of 6 on the left. Rewrite 36 as 6 to the second power. Multiply your exponents over there on the right-hand side. So 2 to the 2x plus 1 would be 6 to the 4x plus 2. So I would have, my bases are the same. 2x is going to equal 4x plus 2. Subtract 4x from both sides. So negative 2x is going to equal 2. Divide both sides by negative 2. X is going to equal negative 1. Moving on to the next one. Trying to make space for myself. Okay. So I have 1/7 raised to the x power. I need that base in the numerator, 7 to the negative 1 to the x power. And I do believe I can rewrite 3,401 with a base of 7. Let's see, 7 to the first power is 7. 7 to the second power is 49. 7 to the third power, 7 times 9 is 63. Sometimes 4 is 28 plus 6 is, so it's 343. 7 to the fourth power, 343 times 7. 7 threes are 21. 28, 29, 30. 7 threes are 21 plus 3 more is 24. So that's it. 2,401. So that's to the fourth power. 7 to the fourth power. So 7 to the fourth power. Multiply your power of a power. So 7 to the negative x is going to equal 7 to the fourth power. And then my bases are the same, so negative x equals 4. Divide by negative 1. X is negative 4. For the next one, we saw 512 back here with 8. So I know I can rewrite 512 with a base of 8. Let's think about it like this. If 8 to the third power is 512, I can rewrite 8 with a base of 2. 2 to what power gives me 8? 3. So 2 to the third, which is 8, raised to the third power is 512. Let me erase. I'm going to erase this multiplying right here. So then 2 to the ninth has to be 512. So 512 needs to go to the numerator. So that would be 512 to the -1 power. And I'm going to bring that other part down. I'm going to rewrite 512 as 2 to the 9th power. And that -1 is still out there because it was in the 512 was in the denominator. Now I'm going to take care of my power of a power by multiplying those two. So 2 to the -9 is 2 to the 3x minus 1. Then I'm going to set my exponents equal to each other. I'm going to add 1 to both sides. So I know -8 is going to equal 3x. Divide by 3, x will equal -8 thirds. Okay, and my last example for this week's notes is 25 to the 2 minus 2x equals 1 over 25. Well, of course we know 25 to the first power is 25. I do believe 25 to the second power, 25 times 25, is 625. So I'm going to leave the left-hand side as 25 to the 2 minus 2x. Let me draw myself a red line just to get this. It's my little doodles on the side. And then 625 I'm going to take to the numerator first and make it have a -1 exponent. And of course x plus 1 is there. And I think I'll go ahead and multiply these two. It'll make my life easier, I believe. So 25 to the 2 minus 2x is going to equal 625 to the -x minus 1. Then I'm going to rewrite 625 as 25 squared. So 25 to the 2 minus 2x is going to equal 25 to the second power. I think I'm going to erase because I need this space right here. Just going to erase that. So sorry if you needed it, but it's running into my problem, what I need to write, and I'm tired of squeezing it in there. So this was x plus 1, and that was a -1. So 625 to the -1 was here with x plus 1. And we distributed the -1, so 625 to the -x minus 1. Now 25 squared to the -x minus 1. 25 to the 2 minus 2x is going to equal, I'm going to distribute 2 to this, 25 to the -2x minus 2. Now my bases are the same, so I can set those equal to each other. 2 minus 2x is going to equal -2 minus 2x. I'm going to add 2x to the other side. So 2 is going to equal -2. And that looks like no solution. I'm going to pause the video and see if I've made a mistake. If I have, I'll redo. If I haven't, then that's the answer. That looks correct to me, so I believe the answer to number 15 is no solution. If you will make sure your weekly practice, and then reach out to me if you need help with these bottom ones. Scientific notation, I believe you learned that last year, but if you need help, just reach out to me. I'll be happy to help you. And then that's it for the week. Have a wonderful week.